Hello everyone and welcome to the first video on World of Coincraft channel. As some of you may know, I'm running a small Twitter channel where I post some creative stuff with a mixture of World of Warcraft, Hearthstone and Crypto Life. You can find the link in the description below. Here on this channel I will try to focus on technical aspects of top trending ICO projects. I should also mention that you won't find here team overviews, token metrics, or my personal opinion on whether you should or should not take part in ICO. I am not a technical specialist, so don't treat this video as professional point of view. I am just some random crypto enthusiast who is in love with blockchain technology and wants to understand how everything works a little bit deeper. So, before diving deep into DxChain architecture and consensus protocols, I think it's reasonable to have a quick look at main technologies on which DxChain is built. It's Hadoop and IPFS. Hadoop is project of Apache Software Foundation, open source distributed set of utilities, libraries and framework for development and implementation of distributed programs that work on clusters from hundreds and thousands of nodes. It is used to implement search and context mechanics of many heavy-loaded sites, such as Yahoo and Facebook. It is designed on Java within the scope of MapReduce paradigm, according to which applications are divided into a big amount of similar primary elements processed on cluster nodes, and then put together into final result in a natural way. Hadoop development started in 2005, and by 2010 Hadoop was recognized as one of fundamental technologies of so-called big data. The base Hadoop framework is composed of the following modules. Hadoop Common contains libraries and utilities needed by other Hadoop modules. Hadoop Distributed File System, or HDFS, is a distributed file system that stores data on commodity machines, providing very high aggregate bandwidth across the cluster. Hadoop Yarn, introduced in 2012, is a platform responsible for managing computing resources in clusters and using them for scheduling users' applications. Hadoop MapReduce is an implementation of the MapReduce programming model for large-scale data processing. Okay, so let's have a closer look at MapReduce technology. MapReduce is composed of two methods. A map method, which performs filtering and sorting, such as sorting students by first name into queues, one queue for each name, and a reduce method, which performs a summary operation, such as counting the number of students in each queue and yielding name frequencies. The MapReduce system, or so-called infrastructure or framework, orchestrates the processing by marshalling the distributed servers, running the various tasks in parallel, managing all communications and data transfers between the various parts of the system, and providing for redundancy and fault tolerance. Another great and innovative technology is Interplanetary File System, or IPFS. IPFS is peer-to-peer and distributed file system that was expected to replace HTTP and to decentralize the internet once again. It is acknowledged that IPFS doesn't have a single point of failure. IPFS technology on blockchain is proposed by Filecoin project. IPFS works by connecting all devices on the network to the same file structure. The file structure is a Merkle deck, word so loved by blockchain community, which combines Merkle trees, which are used in blockchains to ensure immutability, and directed acyclic graphs, which allow users to see versions of content on IPFS. Okay, so all in all, I think these technologies have many common with blockchain technology and can show actually pretty good synergy. Now we can move to DxChain technology itself. To achieve its goals, DxChain consists of three different chains with their own consensus protocols. Side chains use the same token from the master chain, or each can define its own secondary token with network-defined rate. Sidechains communicate with the master chain through the smart contracts. Besides this, sidechains can interoperate with each other through the chain-on-chain microservices, which includes data and messages. Okay, so master chain is main chain with Ethereum compatible data structure and proof of work consensus. Tasks for computation, storage, and their results are being initiated from and received in master chain. Okay, so that was the easiest part, and now to more complicated. Data side chain, or DSC, works as an incentive layer and is not used for data storage. It is used for upload and download of files and verifying and storing of meta information. When data and files are uploaded into DxChain, they are broken into many small pieces and then stored into peer-to-peer storage network, such as IPFS. The main job for the miner in DSC is to provide transfer across the peer-to-peer network and to store meta information on chain. Data side chain use proof of spacetime consensus protocol, or POST. POST evolved from many of its predecessors, for example, provable data possession, which was introduced for allowing a client that has stored data on an untrusted server to verify that the server stored the original data without retrieving it. While provable data possession is a perfect fit for cloud computing storage, it has several limitations for a decentralized network, such as privately verifiable computing. The proof of spacetime is designed to be an improvement over provable data possession, to fit a decentralized environment. To ensure security of information, privacy and public verification, data side chain can use such technologies of zero-knowledge proofs and also apply encryption on different stages of information uploading. Computing side chain, or CSC, has a similar structure to data side chain. It is hash-linked, it contains the header, transaction sets, contracts, and data allocation. The transactions also use the Merkle tree structure. A client sends a computation request to the network, and this request propagates through the network. Each miner uses the computer side chain to obtain tasks. When a task finishes, the working miner sends the confirmation to the CSC to update the task status and obtain incentives. Any computation miner who is interested in working on the task could potentially take the task. The miners, solvers, and verifiers in the computer side chain will load the code and the data into the DxChain virtual machine and execute the code inside the DVM, including parallel computation and verification tasks. Computer side chain utilizes two consensus protocols for different types of computation, two different philosophies to design the validation process. Verification game, which is consensus protocol for computing side chain, provides a framework which enables smart contracts with no need for trust to securely perform any computational task. Moreover, when compared with the computations in traditional Ethereum smart contracts, verification game vastly reduces the number of redundant network node computations. In a verification game, there are several miners' roles with different functions in the system. The core role are solver, challenger, and judge. A solver is a miner who offers a solution to a given task, and a challenger is one who disagrees with the solution from the solver. As far as I understand, judges make only some small parts of computation to check solver and challenger results in a number of verification rounds. Since judges do very small amount of computation, they validate their results between each other through common Nakamoto consensus, proof of work. Verification game does not trust or rely on the reputation of its participants or any trusted party in the system. A deposit is needed to perform a task from both the solver and the challenger. Any faulty party will lose its deposit. Such penalty mechanism will potentially eliminate the untrusted players with the passing of time. Another consensus protocol is provable data computation. In provable data computation, the DxChain team proposes a statistical way to prove the correctness of computation. First of all, they determine number of identical answers they want to get, to be sure that computation is right. In white paper example, they propose 7 identical answers. So, when a computation task is broadcasted through the network, all the nodes start to make computations and give their results. Then we compare results, and when we see first 7 identical answers, we choose it as the right result of computation. In this case, we can only get wrong answer if all the 7 nodes are faulty. Both verification game and provable data computation have advantages and disadvantages. Verification game has a really strong statement. However, it is an interactive verification process and the computation breakdown is not easy to implement in DxChain. Provable data computation has a weak conclusion, but it's enough for most distributed computing. Provable data computation is very easy to apply to distributed computing. DxChain network uses both of these consensus protocols for different scenarios. And finally, I would like to cover some of the Hadoop toolsets in DxChain network. Firstly, DxChain team intends to develop Peek, Hive, and Mahout tools from Hadoop. Peek provides a set of high-level language for expressing data analysis. Peek supports database operations and analysis for non-structured data. If the data is stored as a plain text, Peek is perfect tool to parse and analyze it on the fly. Hive facilitates reading, writing, and managing large datasets residing in distributed storage using SQL. DxChain network supports database schema and SQL is used to do business intelligence related operations. Mahout is a framework to run machine learning algorithms including canopy clustering and principal component analysis. So basically that's all. I hope I managed to cover all the main aspects of DxChain, blockchains and consensus protocols. Thank you for your attention. Don't forget to subscribe to my Twitter channel and bye bye.